Okay, this is about the basic idea of the interference in some thin films. Okay, after this, we'll go for the next, this one. We'll take the billet lens. Okay, we'll discuss the idea behind the Billets lens theory, that one. So first we'll have, what do you mean by that billet lens? So we'll start with this. So there's actually a lens, and this will be the optic axis. Now I'm going to cut the lens into the two equal parts. Then upper part, I'll keep it here. The lower part, I'll keep it here. Look at that, the optic axis. The two brown color lines, what you see now, they'll become the optic axis. Able to understand now? So actually, in fact, this is a lens. Okay, this one. So I'm going to cut it. You see upper and lower part. The upper part, what happened is brought here. Exactly symmetrical, I'll cut it along the optic axis. And the lower part will be brought here. No, what is this? I'm writing some optic axis. This line, horizontal line, will be optic axis for the upper part of the lens. Or what you can say, principal axis. And this horizontal line will be the optic axis for the lower part of the lens. Able to get this one? So this one. So there what happened, I'll put a one block here. So what is this region? So which will block the ray of light, which will not permit the light to pass through it. Like this, a block will be placed here. So I'll keep the source of light of monochromatic wavelength lambda at a distance here. Let a distance be from the combination of lenses here, this one. So in between what happens, there's an opaque substance which will not permit light. Or this part of thing, instead of filling everything, I'll fill up in this region. So any light coming here will be blocked. Getting the idea now? Okay, now let's get into this one. A ray of light emitted by the source. It will emit light in all directions as there is a point source. So a ray of light passing through the lens will undergo refraction and will let it be at point S1 at one point, and another ray will pass through optic center. What are C1, C2 will be optic center for individual lens. What are C1 and C2? I should call them as C1, C2, what they are. C1, C2 are optic centers of upper and lower part of lens. Okay, there's the one very important. And we know any ray passes through optic center should go undeviated. Any ray that passes through optic center should go undeviated. So this ray passing through optic center should go undeviated. And the refraction of two rays will form like an image. Okay, this S1 will become image formed by the upper part of lens for the source S. The S will become like a luminous point source. Similarly, a ray passing through the optic center C2 goes undeviated, will meet the screen or will meet certain point on a vertical line at S2, and another ray I'll send it. So both will undergo, so both will meet at this point. So these are the two refracted rays, so they will form image S2. So what is S2? Shall I say like a S2 is the image formed by the lower part of lens for the luminous point object S. Similarly, what is S1? S1 is the image formed by the upper part of lens for the luminous point object S. Luminous point source S, that one. This S1, S2 will be coherent. They will also have wavelength lambda. S1, S2 will become coherent source of light. Okay, that will indicate what are S1, S2. Coherent source of light produced by billet lens. Getting the idea? This will be okay. Now let's come for this one. What is the for fringe width? So I want this distance between S1 and S2, and I know already capital D. This is screen. This vertical part is screen where we can see the interference bands like alternate bright and dark bands is what we can notice. Getting the idea now? Okay, let's get into the condition here now. So look at this triangle now. So for first we'll do one thing. So what is the distance C? How to calculate this one? How to calculate this distance C? How to calculate this one? Let me use the length equation 1 by V minus 1 by U equal to 1 by F. What is like a V? V will become C. This will be plus C. Then the object is at a distance B minus B. The reason for that, anything directed towards right should positive, because the incident rays are moving towards right. The distances measured in the direction of incident rays should be positive. So therefore C will be positive, whereas B will be negative. And the converging lens, focal length will be positive here. This will be the signs. Solving for C, I'll get equation C is equal to FB by B minus F. So at what distance that coherent sources S1, S2 coherent source images are formed will be, and they'll be on same vertical line because there's a symmetric. They'll be on same vertical line. Getting this one? No. Let me come to the triangle. Triangle S1N from this triangle. Tan theta. So the here like tan theta will be R plus A by 2. I'll separate them by distance A. Here, there's a distance A. Are you noticing this one? So then what is this distance will be? A by 2. A by 2. So what is the triangle from here? Tan theta should be equal to R plus A by 2 by this distance. What is the adjacent will be? B plus C. They should be equal to, look at this triangle. This should be the A by 2 by B from this triangle. So what is tan theta should be equal to opposite by adjacent. What is opposite? Opposite is A by 2 and adjacent is B. So A by 2 by B. Solving for R, I'll get the required equation as R equal to AC by 2B. Okay, fine. Just the ray diagram is very important once you can get it that well. So now what is the distance? This distance how much now? What is this? D is equal to R plus A plus R. So it should be 2R plus A. So what is R is equal to AC by 2B. So 2R should be equal to AC by B. So finally, what is the distance? D is equal to A, C, B, C by B plus 1. Then, so these S1 and S2 or now what happened will be like a coherent sources. So here I can see on the screen interference pattern, alternate bright and dark bands is what I'll notice. They'll not disappear, only I'm showing it, or else we'll draw permanently few. Alternate bright and dark bands will be noticed on the screen. So what is the expression for? So there's the interference pattern. So what is the expression for the fringe width? So what we can write, lambda capital D by small d. What is small d? We have equation CB plus 1, or lambda capital D by this expression for the fringe width. This will be central maxima. CM means central maxima. And this will be the Y. So similar to YDSE, it is. So we'll get expression for the fringe width. What is the advantage is like I can measure this fringe width. I can measure this fringe width using traveling microscope. Using traveling microscope can be measured. Then capital D and B, A, C, B, all these things. So the wavelength of light is unknown, which I can determine. So why do this billet lens I'll use again to measure the wavelength of light? So this is the experimental background. Why we are studying all this one is the wavelength of light is a very difficult parameter to measure. Using this particular concept, it will be very easy for me to measure the wavelength. Okay, this is about the overall, the theoretical idea of the billet lens here. So what that billet lens here, it's just like a ray optics idea, that one. So the the upper and lower part of lens, they'll form images I1 and I2. Those images S1, S2 will become coherent sources of light, and there'll be like a slit, and due to that we are going to see the interference pattern. Next, what you have to ask, like, sir, is it a fringe pattern? Will it be like this? No, I should not say interference pattern. Interference region pattern will not be rectangular bands, because what they are, there's a point sources, no, S1, S2 are what, okay, coherent point sources. So how the pattern will not be like this, will be a alternate bright and dark rings it will be. Just for your understanding purpose, I'm just showing it here. This one, so interference regional, right, rather than this. This is about the billet lens. A very small idea, can be asked in advance. It's an experimental one. Okay, after this we'll take the next one, the Fresnel biprism. Okay, now we are going to